An object moves at constant velocity, so it must have a net force on it, eventually stops due to gravity, not have any forces of gravity, have zero net force on it, or have no frictional force on it. The true answer is D, have zero net forces on it. Explanation: because the object moves with constant velocity, which means that its acceleration equals zero, as its state, both velocity and direction, doesn't change, which means that there is no external force acted upon it to change its state or its velocity. Mass differs from weight in that all objects have weight but some lack mass. Weight is a force and mass is not. The mass of an object is always more than its weight. Mass can be expressed only in the metric system, or there is no difference. The true answer is B. Weight is a force and mass is not. As mass depends on the amount of matter in an object and only changes by changing the amount of matter in an object. As mass doesn't change by changing place, state, or shape, while weight changes by changing place. Also in space, object has mass but it has weightlessness. Mass of the body, space, is slightly different at different places on Earth. Is a vector, is independent on free fall acceleration, is the same for all bodies of the same volume, can be measured most accurately on a spring scale. The true answer is C, is independent on free fall acceleration. Explanation: as mass depends on the amount of matter in an object and only changes by changing the amount of matter in an object. As mass doesn't change by changing place, state, or shape. The mass and weight of a body, space, differ by a factor 9.8, are identical, are the same physical quantities expressed in different units, are both a direct measure of the inertia of the body, have the same ratio as that of any other body placed at that location. The true answer is E, have the same ratio as that of any other body placed at that location. Explanation: you will have a doubt in the first choice as weight equals mass times 9.8. But you should know that the weight of the same body may change with another ratio, as 9.8 or free fall acceleration on Earth itself changes on Earth by changing distance away from the Earth's center. However, you should know that the ratio between weight and mass is constant and equals the free fall acceleration at a certain planet, Earth or any other planet, and depends on the distance between the object and center of gravity. An object placed on an equal arm balance requires 12 kg to balance it. When placed on a spring scale, the scale reads 120 Newton. Everything, balance, scale, set of weights, and object is now transported to the moon, where the free fall acceleration is 1/6 that on Earth. The new readings of the balance and spring scale respectively are space 12 kg and 120 Newton, 2 kg and 20 Newton, 12 kilograms and 20 Newton, 2 kilograms and 120 Newtons, 12 kilograms and 720 Newton. The true answer is D, 12 kilogram and 20 Newton. Explanation: because the mass of the object is constant and doesn't change by changing the place. So mass of object on Earth equals its mass on Moon. When its weight on Moon decreases by 1/6 its weight on Earth. The block shown moves with constant velocity on a horizontal surface. Two of the forces on it are shown. A frictional force exerted by the surface is the only other horizontal force on the block. The frictional force is space 0, 2 Newton leftward, 2 Newton rightward, slightly more than 2 Newton leftward, slightly less than 2 Newton leftward. The true answer is B, 2 Newton leftward. Explanation: summation F, which means the resultant force that acts upon the object, equals F1 minus F2. And as the object moves with constant speed, so summation F equals 0, which means F1 equals F2. 5 equals 3 plus frictional force. So frictional force equals 5 minus 3 equals 2 Newton. A heavy wooden block is dragged by a force F along a rough steel plate, as shown in the diagrams for two cases. The magnitude of the applied force F is the same for both cases. The reaction, which means normal force, in second case is space if compared with the reaction normal force in the first case. The same, greater than, less for some angles of the inclined and greater for others, less or greater depending on the magnitude of the applied force F. The true answer is C, less than. Explanation: because the reaction or normal force in case number 1 equilibrates with the weight of the wooden block, while in case number 2 the reaction or normal force equilibrates with the vertical component of weight, which is less than the weight itself. A 9,000 Newton truck is pushed along a level road by 4 students who apply a total forward force of 500 Newton. Neglecting friction force, the acceleration of the truck is space 0.055 meter per second square, 0.54 meter per second square, 1.8 meter per second square, 9.8 meter per second square, or 18 meter per second square. The true answer is B, 0.54 meter per second square. Explanation: weight of the truck equals mass times gravitational acceleration. So mass of the truck equals 9,000 over 9.8, which equals 918.4 kilogram. And F equals mass times acceleration, which is acquired by the truck. So A equals F over M. 500 over 918.4 equals 0.54 meter per second square. A ball with a weight of 1.5 Newton is thrown at an angle of 30 degrees above the horizontal with an initial speed of 12 meters per second. At its highest point, the net force on the ball is space 9.8 Newton, 30 degrees below horizontal, 0, 9.8 Newton up, 9.8 Newton down, 1.5 Newton down. The true answer is E, 1.5 Newton down. Explanation: as at highest point the ball falls downward under the effect of its weight only, which equals 1.5 Newton. Two forces are applied to a 5 kilogram block. One is 6 Newton to the north and the other is 8 Newton to the west. The magnitude of the acceleration of the block is space 0.5 meter per second square, 2 meter per second square, 2.8 meter per second square, 10 meter per second square, or 50 meter per second square. The true answer is B, 2 meter per second square. Explanation: the net force equals square root 6 square plus 8 square, which equals 10 Newton. As F equals ma, so acceleration equals force over mass, which equals 10 over 5, which equals 2 meter per second square.